Okay, so here the given problem is, let x of n be unit impulse that is defined as x of n is equal to del of n. We need to find out DTFT of this particular signal. So you have to write a formula and you have to substitute the value of x of n in the formula. Here main important thing is del of n is defined over only one time when n is equal to 0. The rest of the thing is equal to 0. Hence the entire equation reduced to 1, that is defined only when n is equal to 0. Hence the DTFT, discrete time Fourier transform of the given sequence is x of e power j omega is equal to 1. At the same time, if you are trying to find out inverse DTFT of x of e power j omega is equal to 1, you will get a sinc function. Okay, sinc function. In the sense, actually, when you are dealing with impulse, I might have told you that impulse is defined over only one time instant, t is equal to 0 or n is equal to 0. And practically, this is actually theoretical one. Practically speaking, it is very difficult to realize or generate this kind of signal, because it's very difficult to exactly generate an impulse when n is equal to 0, and we don't have any switch which have a narrow opening. Instead, actually, when you are zooming these impulses, you will get a pulse something like this, a impulse something like this, and it's very narrow, maybe nanoseconds or microseconds, something like that. And when you are and zooming it, the signal looks like defined at exactly at n is equal to 0. That's why when you are taking inverse Fourier transform, discrete time Fourier transform of x of e power j omega is equal to 1, you will get a sinc function. So this is the inverse Fourier transform equation. Okay, you have to substitute x of e power j is equal to 1 and defined over a small interval, that is minus omega to plus omega. Okay, this one is defined over minus omega to plus omega. During this interval, when you are taking inverse Fourier discrete time Fourier transform, you will get sinc, that is sine omega n by pi n. Now we are going to solve some set of problems related to impulse response. Okay, that is also it's important question related to 5th unit. I'm just moving to 5th unit related to DTFT. So problem says, consider linear time invariant system with impulse response h of n is equal to alpha power n into u of n, and here alpha is less than, magnitude of alpha is less than 1, and suppose that the input to this system is x of n is equal to beta power n u of n, and this beta, magnitude of beta is less than 1, evaluating Fourier transform of h of n and x of n, something like that they have given. So this is related to system. System means a block box which consists of input and output signal. Okay, when I am giving input, that is x of n, it should produce output y of n. Okay, y of n, that is, and the system response is h of n, y of n, and the system response is h of n. This is the important factor. This we have been discussing several times. Okay, now what the problem says they have given the value of h of n and x of n. We need to find out y of n. We have two time sequence h of n and h of n. When you are giving x of n via a system whose impulse response is h of n, then output is y of n, and this y of n is nothing but convolution of x and h. And I told you that convolution is a tedious job when we are comparing with multiplication. Hence, what we are going to do is, we are going to take DTFT of x of n, DTFT of h of n, and then we are going to multiply DTFT of x of n and h of n. Later, we are going to produce, or we are going to take inverse DTFT to produce the output. This is the procedure. Hence, I am going to give you a transfer function h of e power j omega is equal to, it's the ratio of DTFT of y of n and DTFT of x of n. Okay, so y of e power j omega is multiplication of h and x in transform domain. In time domain, it's convolution, and in transform domain, these, when you are multiplying these two things, you will get output. Hence, I am going to separately find out discrete time Fourier transform of h of n and x of n. So, these are the two important terms. So, DTFT of h of n is h of e power j omega, which is equal to 1 by 1 minus alpha into e power j omega. This is standard formula. And x of e power j omega is equal to 1 by 1 minus beta into e power j omega. Now, we are going to find out the output. Y of e power j omega is the multiplication of h of e power j omega and x of e power j omega. We are going to multiply these two terms. I will get 1 by 1 minus alpha and e power j omega minus j omega into 1 minus beta and e power minus j omega. Now, we need to find out inverse DTFT of y of e power j omega to find the output of the system. Okay, I have two terms. I have to use partial fraction to separate or decompose two terms to small term. Hence, I am writing. Okay, so this is mainly used to find inverse DTFT of the given system equation, that is y of e power j omega. I am going to decompose by writing like a by 1 minus alpha and e power minus j omega plus b by 1 minus beta and e power minus j omega. So, then we have to find the value of a and b. A and b values need to be determined by equating right hand side of this equation, that is this one and this equation. We have to equate these two things and find out value of a and b. A value, when you are equating, you know I think I hope you are also familiar with the partial fraction, and we have done few problems related to partial fraction in previous unit module. So, I will get a is equal to alpha divided by alpha minus beta, and beta b is equal to b minus beta divided by alpha minus beta. I have to substitute a and b in this equation. I have to substitute in this equation, and I have to take inverse DTFT. After substituting and taking inverse transform, I will get y of n is equal to alpha divided by alpha minus beta into inverse transform of 1 by alpha and e power minus j omega is alpha power n into u of n, and minus beta divided by alpha minus beta power n into u of n. So, this is the response of the given signal, and of course, you have to take a common thing outside, and they have written the result. So, this is the simple way to find out the response of the signal, response of the system when you have input and system response. And next thing is properties of discrete time Fourier transform. So, of course, you are also familiar with the properties of Fourier transform, Laplace transform, and And also, and also I've already told you that a few properties are so important, and the same properties here we are going to discuss. The rest you can just have a look in the book. Now, first important property is linearity property. Linearity property says linear combination of two different input leads to linear combination of two different transform domain signal. For example, when you are taking x1 is the input signal, and DTFT of x1 is x1 of e power j omega, x2 of n, the value is x2 of e power j omega. When you are combining x1 and x2, there is linear combination, that is a into x1 of n plus b into x2 of n, and then if you are taking Fourier discrete time Fourier transform, you should get a into x1 of e power j omega plus b into x2 of e power j omega. If you are getting this result, then the system is said to be linear. If it is not, then the system is said to be non-linear. The proof for this particular linearity property, just assume yes, this one, DTFT of alpha into x1 plus beta into x2. So, if you are taking DTFT of alpha and x1 plus alpha and x2, here alpha and beta both are constant. Okay, any scalar, real or complex numbers, and x1 and x2 are any two discrete time signal. Okay, when you are taking DTFT of linear combination of these two signal, and you should get this result that we are going to now prove it. For example, I am going to take this one, that is DTFT of alpha and x1 plus beta and x2. Okay, for this particular case, the transform is summation. You have to write the formula summation n is equal to minus infinity plus infinity alpha and x1 of n plus beta and x2 of n and e power minus j omega n. Now I am going to multiply e power minus j omega inside the bracket. What I will get is, and also I am going to take constant outside. This alpha and beta are constant, and also I am going to separate two, because I have two different terms. I am going to separate two different terms. So when I am doing like that, I will get alpha into summation n is equal to minus infinity plus infinity x1 of n into e power minus j omega n plus beta into summation n is equal to minus infinity plus infinity x2 of n into e power minus j omega n, and this is nothing but x1 of omega, and the second term is nothing but x2 of omega. So what I have done is linear DTFT of linear combination of two input signal leads to linear combination of Fourier transform of, that is discrete time Fourier transform of two different the same two different signal. Hence the linearity property is proved, that is it's satisfying superposition theorem as well as scaling theorem. Next property is time shifting and frequency shifting. So we are going to study what will happen to DTFT when you are introducing a small delay or shift in the input signal. For that, first consider x of n, and whose DTFT is x of e power j omega. Now we are going to introduce a shift or delay in the input signal by substituting n is equal to n minus n naught. When I am substituting n minus n naught, I will get e power minus j omega n naught into x of e power j omega. I'll prove this in the next slide. So this is the DTFT of x of n minus n naught. When you are taking DTFT of this one, x of n minus n naught, you will get e power minus j omega n naught into x of e power minus j omega. I want you to remember this property throughout discussion, not only this, for rest of the course, because this time shifting property has variety of application in drawing block diagram and solving differential equations, etc., etc. So I want you to remember this property. I'm going to definitely ask this question when I'm taking differential equation. Now, again I'm reading DTFT of x of n minus n naught. If you are taking DTFT of x of n minus n naught, you will get e power minus j omega n naught into x of e power j omega. Similarly, if you are taking DTFT of e power j omega naught into n naught, e power omega j omega naught into n x of n, you will get x of e power j omega minus omega naught. This is a frequency shift, and this one is time shift. First one is time shift and second one is frequency shift. So proof for time shifting. So here we are purposely introducing a delay or shift in the input signal and finding DTFT. Okay, you know DTFT formula, and I'm simply substituting, I'm replacing n is equal to n minus L, n minus L, that's it. Okay, if I am introducing n minus L, what is going to happen, that we are going to see now. So DTFT of x of n minus L, for this case, when I am substituting in this equation, I will get, that is DTFT equation, I will get summation n is equal to minus 50 plus 20 x of n minus L into e power minus j omega n. Now I am going to substitute or consider m is equal to n minus L. When I am substituting m is equal to n minus L, there will not be any change in the lower and upper range of summation because both are infinity. Whatever may be the case, when you are substituting n is equal to infinity, you will get m is equal to infinity. For minus infinity also, you will get the same thing. But here there will be some change in the after summation. So I am substituting n minus L. This n minus L, I am just replacing n minus L by m. So what will happen is, so x of n, and I have e power minus j omega n here. So m is equal to n minus L, then n is equal to m plus L. N is equal to m plus L. So I am just replacing n by m plus L. So I will get e power minus j omega m plus L. Now I have two terms. I am going to separate into two different exponential, and so I am rewriting this equation like m is equal to minus into plus infinity x of m into e power minus j omega m into e power minus j omega L. Here this term is constant, it's not a variable, so I am going to take it outside of the summation. What I will get, summation m is equal to minus into plus infinity x of m into e power minus j omega m. This is nothing but x of omega. So this property says, if you are introducing some shift or delay, the same quantity of exponential e power minus j omega some quantity will come out when you are taking DFT, that's it. Okay, whatever may be the value of the delay. So here I introduced L, hence I get e power minus j omega L. If I am introducing n naught, then I will get e power minus j omega n naught, that's it. So third one is convolution property. Again I am saying this is very important property. Convolution of two different signal in time domain will become multiplication in frequency domain. This is the property of this is the definition of convolution property, and the equation related to convolution summation is given here. X of n convolution y of n can be written like summation m is equal to minus into plus infinity x of m into y of n minus m. We will have a detailed discussion about this topic later. I am just giving the formula, and we will discuss about the same maybe next class. Now we are going to take Fourier discrete time Fourier transform of convolution of two different signals, that is x of n and h of n, that is DTFT of x of n convolution y of n. So first you write the formula to find out DTFT and just replace x of n by this particular term. So what I will get is summation n is equal to minus to plus infinity x of n convolution y of n into e power minus j omega n. This is the formula to find out DTFT of the given signal. Now I am going to substitute the formula to find out convolution of two different signal. This formula I am going to write it. So I am just replacing x of n convolution y of n by this the equation. I will get summation n is equal to minus to plus infinity, and again the formula to find out convolution two different signal is summation m is equal to minus into plus infinity x of m into y of n minus m into e power minus j omega n. Okay, now I am going to take some term because I'm going to change the order, the place of summation. So I'm going to change the place of summation. So I'm going to take the summation before. I'm going to move this summation, second summation before the first one. That is, I'll get summation m is equal to minus plus infinity x of m into summation n is equal to minus into plus infinity y of n minus m into e power minus j omega n. Okay, by applying the time shifting property, by substituting time shifting property, I can write this equation like here the delay is m, the delay value is m, hence I am going to replace this equation using e power minus j omega m into y of k. Okay, sorry, y of omega, not k, omega, y of omega. Okay, and I have when I am doing like that, I'll get, okay, so when I am doing like that, I will get a remaining thing is e power minus j omega m. Okay, by substituting n minus m is equal to some constant, some k or something like that. When I do it like that, and you will get the remaining things. So I am going to separate into two different terms. One is e power minus j omega m. Okay, this particular term I am going to multiply with the first term. Okay, when I am multiplying these two terms, this is nothing but a discrete time Fourier transform of x of omega. Okay, so simple thing is I am going to use time shifting property to find out Fourier transform of the second term. By introducing time shifting property, I will get a term e power minus j omega m into omega y of omega. So this e power j omega I am going to multiply with the first summation, and when I am doing like that, I will get DTFT of x of omega. Hence I will get the result like x of omega and y of omega. So what we have done is we have taken discrete Fourier transform of convolution of two signal x of n and y of n. This convolution becomes multiplication in Fourier domain. This is a proof for this property, that is convolution will become multiplication in frequency domain. And this is also one of important problem. Pascal-was relation. It says summation n is equal to minus into plus infinity magnitude of x of n the whole square is equal to 1 by 2 pi integration over 2 pi x of e power j omega magnitude square into d omega. This is also an important property of discrete time Fourier transform. And of course I have listed some important properties of discrete time Fourier transform like linearity, time shifting, frequency shifting, conjugation, time reversal, time expansion, convolution, multiplication, differentiation in time, accumulation, differentiation in frequency. These are the important properties of discrete, not only discrete time Fourier transform, and of course you can even use the same set of properties for other transforms also. with this, I am stopping discrete and Fourier transform, and now I am going to discuss some topics related to fifth unit, that is system linear time invariant system modeled or represented using discrete time Fourier transform. I hope you are all so familiar with the differential equations that we have discussed in third unit. There we have used d by dt, d square by dt square, etc., etc. The same set of differential equations and the equation which we used in third unit, we are going to call it as difference equation. Okay, there we have used differential equation. Here the same set of slides, but we are going to call it as difference equation. And you can, of course, I have given the material for third unit. You can even compare third unit and fifth unit. There won't be much difference between third and fifth unit. Only difference is there. You might have used differential equation. Here we are going to use difference equation. Okay, now I'm just reading the definition of difference equation, etc. System characterized by linear constant coefficient difference equation. Now, a general linear constant coefficient difference equation of a linear time invariant system with input x of n and output y of n is in the form of summation k is equal to 0 to n a suffix k y of n minus k is equal to summation k is equal to 0 to m b suffix k into x of n minus k. If possible, I will compare, not now, maybe tomorrow, I will compare differential equation and difference equation the next class. When you are taking discrete and Fourier transform of this equation, this is actually summation. So you have to substitute different values to this k. This expression will expand. For example, if you are substituting k is equal to 0, you will get a naught y of n plus a1 y of n minus 1 plus a2 y of n minus 2, and it will go up to a n y of n minus capital N. Similarly, when you are substituting different values to right hand side of the equation, you will get b naught x of n plus b1 x of n minus 1, and it will go up to bm x of n minus m. When you are taking discrete and Fourier transform on both sides, again I am saying referring time shifting property. Here a delay or shift is introduced in this equation. So depends upon the value of this delay, you have to multiply e power minus j omega. That's it. When I am taking this discrete and Fourier transform of this equation, I will get a summation n is equal to k is equal to 0 to capital N a suffix k, because it's a constant. When you are taking discrete and Fourier transform of y of n minus k, I will get e power minus j k omega into y of e power j omega, which is equal to summation k is equal to 0 to m p suffix k, and here the shift or delay is e power minus j k omega into x of e power j omega. Now we are going to take transfer function. We are going to find transfer function. Transfer function is h of e power minus e power j omega. So transfer function of any system is the ratio of DTFT of output to DTFT of input. Output is y of e power j omega and input is x of e power j omega. So we have two terms, y of e power j omega and x of e power j omega. We are going to find the ratio of these two things, and of course this summation, okay, this summation, there is no relationship between this summation and the transform of input and output signal, because I don't find any k in this x of e power j omega and y of e power j omega. Hence I am going to write this equation like h of e power j omega is equal to y of e power j omega divided by x of e power j omega, which is equal to the ratio of these two functions, that is summation k is equal to 0 to m b suffix k e power minus j omega j k omega divided by summation k is equal to 0 to n a suffix k e power minus j k omega. With this small introduction, we are going to solve a problem. Consider the causal LTI system that is characterized by the difference equation y of n minus a into y of n minus 1 is equal to x of n. Determine frequency response of the system. Frequency response or impulse response, no problem. Response of the system. So first I have written this equation. Okay, y of n is equal to a into y of n minus 1 is equal to x of n. I am going to take discrete time Fourier transform of the given system equation. Discrete time Fourier transform of y of n is y of e power j omega. There is no change in a because a is constant. Discrete time Fourier transform of y of n minus 1 is e power, here I have not mentioned this one, e power j omega. I left it, okay, e power minus j omega. And because there is a small shift is introduced or shift or delay introduced in the output y of n minus 1, because of that the discrete time Fourier transform of this particular delayed version of the output signal is e power minus j omega into y of e power j omega is equal to x of e power j omega. Now I am going to take this e power j omega outside. When I am taking y of e power j omega outside, I will get 1 minus a into e power minus j omega is equal to x of e power j omega. Now I am going to take the ratio, transfer function, that is y of e power j omega by x of e power j omega. I will get 1 divided by 1 minus a into e power minus j omega. So this is the transfer function of the system given in the problem. The transfer function of the problem given is y of n minus a into y of n minus 1 is equal to x of n. When you are taking inverse discrete time Fourier transform, here this is again the standard formula. When you are taking inverse discrete time Fourier transform, I will get h of n is equal to a power n into u of n. So this is what the problem, the thing asked in the problem. Okay, now it's very simple to draw the response of this signal particular transfer function, because this we have discussed in the previous class. So I want you to refer the same set of problem we have discussed in DTFT and draw the plot. And inverse DTFT of this problem, this particular case, is h of n is equal to a power into u of n. Next problem is, consider a causal LTI system that is characterized by the difference equation y of n is equal to equation y of n minus 3 by 4 y of n minus 1 plus 1 by 8 y of n minus 2 is equal to 2 into x of n. 2 into x of n. This case we have to take DTFT, okay, and we have to find the transfer. I have directly written the transfer function by seeing this transfer function. So by seeing this problem, I have directly written the transfer function. Transfer function is nothing but y of e power j omega by x of e power j omega. That is, you have to take a discrete time Fourier transform. If you are taking discrete time Fourier transform of this equation, what you will get? Y of e power j omega minus 3 by 4 e power minus j omega plus 1 by 8 e power minus 2 j omega. So definitely this part will be the denominator, and numerator you have only 2. Hence I am directly writing transfer function of the given equation like h of e power j omega is equal to 2 by 1 minus, just see this equation and you can directly write it. So 1 y of n, the delay is n minus 1, hence e power j omega, e power for n minus 2 e power minus j omega, and there is no change in the coefficient. 1 minus 3 by 4 e power j omega plus 1 by 8 e power minus j omega. Simply have found the transfer function of the given system equation. Now I have to find inverse for discrete time Fourier transform of this frequency response to find out the impulse response. Okay, for that I have to use partial fraction method to decompose the transfer function into small part. So you have to use a partial fraction method to decompose it. When I am decomposing this equation, I will get 4 by 1 minus 2 e power minus j omega minus 2 by 1 minus 4 e power minus j omega, and you have to find out the value of 2 and 4 and 2. You have to find these values by substituting, by decomposing this signal into a by first term and plus b by the second term, and you have to equate with the result and find a and b value. A value is 4 and b value is minus 2. After doing this, you have to take inverse discrete time Fourier transform. Here inverse Fourier transform of this term is 4 into, because the coefficient is 4 into, here the coefficient of e power j minus j omega is 1 by 2, so 1 by 2 power n into u of n, and minus 2 into the coefficient of e power minus j omega is 1 by 4 power n into u of n. This is the inverse DTFT of the transfer function h of e power j omega. Okay, then what is this? Sorry, so this we will discuss later because it's a advanced problem. Okay, with this I'm going to stop discrete time Fourier transform. I must thank Sunil sir given this class, because so within this week I have to complete fourth and fifth unit. So now I have confident that I can complete fourth and fifth unit. Maximum part of